Hello and welcome back to your second week of maths. So we are starting a brand new topic for this week and next week and maybe the week after. We'll see how we go. So what are we doing? Well, today we are going to be introduced to the concepts of ratio and proportion. Okay, so this is our new topic, and ratio is one of my favourite things to teach because it comes into everything. You have been using ratio without even realising that you've been using it. We use it when we did metric measurements and imperial measurements a few weeks ago, but you didn't even know that you were doing it. Okay, so I think you will really like this topic and hopefully you will be finding it quite easy as we move through. So this is new learning practice. We have not covered this before, and we are doing it so that we can compare two quantities. So when I say quantities, I mean amounts. We're comparing two amounts of things. Right, write the short date at the top of your page, and let's get started. So to do a ratio, we need to be really confident with our times tables and our division facts. So what I'd like you to do is I'd like you to pause the video now. I would like you to go on to hit the button. So just go on to Google, type in hit the button. I would like you to click on division facts. You can see I've circled it there for you. You can choose any times table. If you really want to challenge yourselves, you can do mixed times tables. And I want you just to spend a few minutes, have a few goes on your division fact. Try and improve your score every single time. Off we go. Okay then, hopefully you are now restarting the video and you are now super confident with lots of division facts and you're using your times tables as well. Right, we're now going to use those division facts to have a look at these fractions. I'm going to put my screen up actually so we can't see them all. Right, this is a rewind. We have done this before. So if I gave you this fraction, is this in the simplest form? No, it's not in the simplest form, is it? It's not the easiest way we can look at this fraction. What can we do to turn this into the simplest form? Well, we need to use our division facts. Look at that. It's like I've done this, isn't it? So we need to use our division facts. You need to think about what can you divide 6 and 8 by? What is a common factor of 6 and 8? Well, I can hear you shouting it through the screens at me. They're both even. Therefore, you can divide them both by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Can you divide these or simplify these any further? Can you simplify this fraction? Well, no, we can't. Why? Well, because this is a prime number, so it only has factors of 1 and 3, and 1 and 3 are not factors of 4. So that stays there. That is it in its simplest form. Next one. Can we simplify it? Well, they're not both even, so I can't divide them both by 2, but 3 is a common factor. So this is the same as 1/2 if I divide them both by 3. Now you can see that because 3 is half of 6. The last one then, 10/60. Can we simplify it? Yes, we can. What can we divide both these numbers by? We can divide them both by 10, which would be 1/6. Brilliant, well done. Hopefully you remembered that from the fractions. So let's play our lesson then. Let's start learning about ratio. Okay. For every something, there are something. So ratio is all about comparing quantities. It's all about saying for every this, you need this. So a really easy way to think about ratio is recipes. When you're making a recipe, you need to have a certain amount of this to a certain amount of this. Let's say, for example, I was making a cake and the cake said I needed 1 egg for every 200 grams of flour. I don't make cakes. That could be a horrible recipe. Sorry, don't try that one. If I then doubled the amount of flour, but I didn't double the amount of egg, I left it as 1 egg, that cake is going to be really floury. It's not going to have enough egg in it. If I took that recipe and rather than putting 1 egg in, I put 6 eggs in, but I didn't times the amount of flour by 6, and have a very eggy, very wet cake. It was not going to be very nice. So the ratio makes sure that we either build things up or we make them smaller by the same proportion. Okay, we want to keep things at the same level as each other. Okay, let's rewind back then to when we made our Victorian broth, our Victorian stew, and we used these vegetables. Can you remember what they are? Well, we've got potatoes along the top and we've got turnips. I think they are turnips. So I want you to think, what is the number sentence? For every something, there are something. Go. So hopefully you can say for every 3, and I would write potatoes, but it's taking me a very long time. So for every 3 potatoes, there are 2 turnips. Nice and easy. So if in my recipe, I put 3 potatoes in. For every 3 potatoes, I put 2 turnips. Okay, what about if I put 6 potatoes then? I'd need how many turnips? 4. I've doubled the potatoes, I'd double the turnips. If I put 9 potatoes in, I've times it by 3. So then I times the turnips by 3, 6 turnips. So for every 3 potatoes, you have to use 2 turnips. This one then, can you fill in the blanks to make my sentence? So careful for this one. So 1, 2, 3, 4, 5, 6. So for every 6, I'll have a go at writing carrots. For every 6 carrots, there are what? There are 3 onions. This is why I don't write on the computer. There we go. So for every 6 carrots, there are 3 onions. What about if I had 12 carrots? So for every 6 carrots, I have to have 3 onions. So I've got 6 carrots, 3 onions, another 6 carrots to make 12, another 3 onions. So I would have 6 onions. What about if I had, this makes one person's stew. Let's say I had 10 people over. So I would have to have 60 carrots. So how many onions would I have to have then to make sure those ratios are the same? Well, I would need 30. Okay, so whatever we times one side of the ratio by, we have to times the other side by. Nice and easy. So for every 6 carrots, there are 3 onions. Okay then, a little bit of a prove it. Thinking about this in a slightly different way. So this is a ratio, but I now want you to prove it by thinking about this as a fraction. What fraction of the vegetables are carrots? Right, well, let's think about this then. So we've got how many carrots? Well, we've got 6. And it's out of what? What's the total amount of vegetables? Well, there's 9. So 6/9 of this lot of vegetables is carrots. Can we simplify that? Yes, we can divide it both by 3. So this is the same as saying 2/3. So 2/3 of the vegetables are carrots. What fraction of vegetables are onions then? Well, if 2/3 are carrots, 1/3 would be onions. Nice and easy. Right then, this time we've got turnips and we've got onions. Go. Okay, then I'm going to try and type it this time. I think this is going to be easier. Should have done this sooner, shouldn't I? So for every 4 turnips, there are how many onions? 1, 2, 3, 4, 5. There are 6 onions. So for every 4 turnips, there are 6 onions. Nice and easy? Nice and easy. Okay then. Let's put them on the side so we can see it. Okay. Is there a simpler way? Is there a simpler way that I could write that? Is there an easier way that I could write that? That still means the same thing, but it's simpler. A little bit like earlier when we were simplifying those fractions. Is there a simpler way of writing this? What can I divide 4 and 6 by? I need to divide them by the same things. I need to do the same to one side as the ratio as I do to the other. Well, if I divide 4 by, they're both even, so I can divide them both by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. It's just the same ratio. Well, for every 2 turnips, there are 3 onions. So if I got another lot of turnips and another lot of onions, I would now have 4 turnips and 6 onions. And look, that is the same ratio that I had before. Okay, so with the ratio, you have to keep the quantities the same. So whatever you do to one side, you have to do to the other a little bit like when we're looking at fractions and we are simplifying them or finding equivalent fractions. You've got to keep those proportions the same. Right, let's prove it then. What fraction of the vegetables are turnips? Well, there are how many? There's 4. Out of how many vegetables? Out of 10, if we count all of them. So 4 out of 10, so 4/10 of the vegetables are turnips. Let's change colour. Let's put a T for turnip. What would the onions be then? If the turnips are 4/10, the onions would be the rest, so they would be 6/10. Can we simplify? Can we make those figures easier to work with? Well, I can divide this by 2, which would be 2 out of 5. I can divide this by 2, which would be 3 out of 5. And I know they're right because together they would add up to 5/5, and 5/5 is a whole, and we want the whole of the vegetables. What do you notice? What do you notice? Well, hopefully you notice that when we simplify our fractions and when we simplified our ratio, we get the same answers. There was 4 turnips, there's the 4 out of 10. Simplify that to get 2 turnips, and look, 2, and now it's only out of 5. So there was 6 onions, there's my 6 out of 10 onions. Then I simplified it to get 3 out of 5 vegetables. So there's my 3. Okay, so there's a real relationship between fractions and ratios. And we simplify fractions in the same way that we simplify ratios. Okay, you have to find the common factors, divide them by that, and it's exactly the same way of doing it. It's just a different way of writing it. Okay, hopefully you're with me so far. It's really hard to know when I'm teaching through a screen whether I'm making sense or not. So fingers crossed you're with me so far. Okay, this is what I want us to write down into our blue books. So ratio is a part-to-part comparison. So you've got a part compared to another part, and the total number of parts make my whole. Okay, so ratios is a part-to-part comparison. So what this means is, that for every 4 parts turnips, there are 6 parts that are onions. Part to part, 4 turnips, 6 onions. For every 4 parts of turnip, there are 6 parts of onion. And together, that makes the total number of parts that make my whole. So I've got 4 parts turnip, 6 parts onion. My whole altogether would be 10, because I've got 10 vegetables. Right, let's change this then. Let's go back to the cake one, because I like that. Let's say for every 2 eggs, there are, let's go for 4 chocolate bars. Maybe we're making like a brownie or something like that. That sounds like my kind of recipe. So ratio, say it with me, is a part-to-part comparison. What's ratio? It's a part-to-part comparison. So for every 2 eggs, there are 4 chocolate bars. So my part is 2 parts egg, 4 parts chocolate, and my total number of parts to make my whole is what then? How much food makes my whole altogether? I've got 2 parts egg, 4 parts chocolate. My whole would be 6. Lovely. Let's keep going. Okay, then. Hopefully you're with me so far. When you are looked on this screen, those of you that were super observant may have noticed a little colon sitting in the middle. Now, colons can be used for all sorts in English, but in maths, they're used for something else. So for maths, we use this symbol here to represent ratio. And it represents that kind of comparison between this side and this side, between these 2 things. So here we are then. So we've got the same word sentences, that's all I'm looking for, isn't it really? Sentences that we had earlier, but we've also got this little colon down here to represent a ratio. Okay, let's have a go through this one together. So for every what, there are what? Well, for every, move them over here actually, can't we? For every how many potatoes? For every 3 potatoes, there are 2 turnips. And these definitely are turnips. Decided. So for every 3 potatoes, there are 2 turnips. Right, I'm going to write that then as a ratio, because otherwise it's quite wordy to say it every time. So, and I've labelled it at the top, look, so I don't get confused. So there are 3 parts potato. Oh, it says onions. I shouldn't say onions, should it? That should say turnips. I've checked, and they are definitely turnips. Ooh, there we go. So for 3 parts potato, there are 2 parts turnip. So we can say 3 to 2. There's 3 potatoes for every 2 turnips. 3 to 2. What would my whole be? How many parts are there altogether? Well, 3 add 2, so it's 3 potatoes, 2 turnips. So altogether, my whole would be 5. There's 5 parts altogether. Right, bonus question for you then. What fraction of the vegetables are potatoes? Go. Well, I know that my whole is 5, because 3 add 2 makes 5. There's 3 potatoes, so 3/5 would be potato. Another bonus question then, what would turnips be? Well, we know it's out of 5. There's 5 parts make my whole, and there's 2 turnips, so it would be 2/5. And these 2 add together to make 5/5, because that makes a whole. Lovely. It's coming together for me. I hope it is for you as well. Right, next one. Oh, that was it. Let's try one more, I think. So let's have for every 3 boys, there are 2 girls. Okay, let's say this is representative of our class. Not quite, but you know. So for every 3 boys, there are 2 girls. What would the ratio be? Can you write this into your book? What would the ratio be? How would you write this as a ratio using that colon sign? So you need your little colon sign to show ratio. So I'm going to put a B up here for boys and a G for girls. And that's just so I don't get confused. So I don't think that there's 3 girls for every 2 boys. So boys, there's 3 boys, girls, 2 girls. So the ratio is 3 to 2. Okay, let's have a go then at our discover. So we have got Mrs. Dean, and we are on some kind of camping trip, some kind of residential trip. So Mrs. Dean is saying, we need to sort ourselves into equal groups for the walk. My problem says, sort the children and adults into equal groups. So you need a certain number of adults to a certain number of children. So you can't have all the adults in one group, all the children in the other group. You need the same amount of adults in each group and the same amount of children in each group. So use the groups you have made to complete this sentence. Oh, we can do this. For every something adults, or for every something adult, there are something children. If you can do that, little bonus, could you write it as a ratio? When you've done that, B, write a sentence to compare how many bananas and how many apples there are. So remember, ratio is a part-to-part comparison. We are comparing. So we need to compare how many bananas to apples. Pause video and have a go. Right then, let's go through this. So when I read this question, I can see that it wants me to sort out children and adults. So first of all, I'm going to try and count the amount of children. So I've got 1, 2, 3, 4, 5, 6. So I'm going to put a C for children, and I'm going to write 6 underneath so I don't forget it. I'm going to keep this really clear in my head. Right, there's 1, 2 adults. So I'm going to write A for adults, and I'm going to write 2. I'm going to put my little colon there. So for every 6 children, there are 2 adults. Okay, happy with that. Let me look at the question then. For every something adult, there are something children. Right. I'm going to turn my ratio round because this one asks for adults first and mine has got adults second. So I'm going to rewrite this. So I'm going to put adults 2, and then C for children, 6, my colon there. Because you can do that with a ratio. You can change the order of the ratio round. It doesn't matter. Okay, it means the same thing. You can have 6 children to 2 adults or 2 adults to 6 children. You're saying the same thing. But that's why it's important that we label it. Because if we don't put those labels at the top, you might say that it's 6 adults to 2 children. And that would be wrong. You've got your nouns the wrong way around. Okay, so I've got 2 adults to 6 children. But this says for every adult, just one, not plural. Let's look at this ratio then. Is there a way that we could simplify this ratio to make it easier to work with? Well, I know that 2 and 6 are both even, so I know I can divide them both by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So for every one adult, there are 3 children. Right, let's check this then. Let's check my answer. Right, well, there's my one adult, and she's got 1, 2, 3 children with her. There's one adult, and he's got 1, 2, 3 children with him. So it works. So my answer should be 1 adult for every 3 children. Right, let's get rid of this, and let's have a go at the next one. Okay, then. Write a sentence to compare how many bananas and how many apples there are. Right, I'm going to write B for bananas and I'm going to write A for apples because don't get them mixed up. I'm going to put my little colon in there because I know that means ratio and it means I'm comparing parts. Okay, well, I'm going to have to zoom in a little bit for this one. So bananas, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 bananas. Hopefully I counted that correctly. Apples there, 1, 2, 3, 4, 5, 6. So what would my sentence be? Well, my sentence would be for every 9 bananas, there are 6 apples. So for every 9 bananas, there are 6 apples. Or I could say for every 6 apples, there are 9 bananas. Right. Is there a way, a simpler way I could write this? Oh, I know I can divide them both by 3. So this is the same as 3. For every 3 bananas, there are 2 apples. Really well done if you got that right. Perfect. There we go. Let's move on. Okay then. A camping, so this is our think together. A camping group takes sandwiches on a walk. Some sandwiches are cheese and some are cucumber. Ugh, my absolute least favourite. I would not be eating the cucumber ones because I can't stand cucumber. Fun fact about me. So can you complete the ratio sentences to compare the number of sandwiches? Okay, pause video, off we go. Okay then, so here's my cheese. I'm going to put ch so I don't get confused. I'm going to put C for cucumber. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cheese. Always label your work. And there's 1, 2, 3, 4, 5, 6 disgusting cucumber. Okay, for every cucumber sandwich, there are how many cheese sandwiches? Right, well, let's write this as a ratio because that always helps me. So cheese, 12, colon, because that compares my ratio. Cucumber, there are 6. Okay then, this says for every cucumber sandwich, again, it's not plural. So this tells me I need to simplify this ratio to find out what one sandwich is the same as in cheese sandwiches. So what can I divide 12 and 6 by? How can I simplify these numbers? What's a common factor? Well, I can divide them both by 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. So for every cucumber sandwich, there's how many cheese? Make sure you get this the right way around. So for cucumber, for every 1 cucumber sandwich, there are 2 cheese sandwiches. And for every 2 cheese sandwiches, there is 1 cucumber sandwich. Well done if you got that right. Okay, pause video. Next one, off we go. Really noisy water bottle. Right, okay, let's have a go at this one then. So this one is a bit more of an explanation one. So Danny's got these coins and Lexi has got these coins. And Danny's saying, for every 8 coins I have, Lexi has 6. Is Danny correct? Okay, let's find out then. So D for Danny, so I don't get confused. And Danny's got 1, 2, 3, 4, 5, 6, 7, 8. So he has got 8. So let's do D for Danny. He's got 8. Lexi, 1, 2, 3, 4, 5, 6. Lexi has got 6. Let's compare them using ratio. Right, do you agree? For every 8 coins he has, Lexi has 6. Do we agree? Yeah, I agree with that. Okay, for every 8 coins Annie's got, Lexi has got 6. Perfect. Write another ratio sentence to compare the coins. Right, can we simplify this ratio? Well, these are both even numbers, so we can divide them both by 2. So 8 divided by 2 is 4. 6 divided by 2 is 3. So we could say for every 4 coins that Danny has, Lexi has 3. Well done if you got those right. So here we are then on our independent activity. So you have got 2 questions here and then 2 more on the next page. So you can pause the video and have a go. And here are the last 2. Let me make it a little bit smaller so you can see it a little bit better. Here are your next 2. And that's it. And you're done for your introduction to ratio. Hopefully it all made sense. Hopefully you understood. Right then, let's go through these. Okay then, so first one is sort the fruit into equal groups. Okay, so I'm going to put 1 apple together with 2 pears, and then this apple is going to have these 2 pears, and then this last apple is going to have these 2 pears. So for every 1 apple, there are 2 pears, and for every 2 pears, there is 1 apple. Because remember, you can write the ratios either way around, doesn't change it. Okay then, complete the sentences for the pencils and rulers. Well, I'm going to do the same thing that I just did earlier because I think that is going to help me. Okay then. So I'm looking at this one and I can't do 1 pencil. Oh, excuse me. It's really cold in my house. That's why I'm sneezing. So we can't do 1 pencil for 1 ruler, because then I would run out. Okay, 1 pencil for 2 rulers wouldn't really work either, because I'd run out then. Right, let's see if we can count these up. So I've got 1, 2, 3, 4, 5, 6. I've got 6 pencils. I'm going to write P for pencil. I'm going to write R for ruler. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my goodness, what is going on with my laptop? There we go. 6 pencils for 9 rulers. So you could write that down for every, right, let me get it the right way around. So for every 9 rulers, there are 6 pencils, and for every 6 pencils, there are 9 rulers. Okay then, fractions then. What percentage of the objects are rulers? Well, I've got 6 parts pencils, 9 parts rulers, so my total would be what? Be 6 add 9, which is 15. So 9 out of 15 are rulers, which tells me that 6 out of 15 are pencils. However, there was another answer to this question. So some of you, by proving it, will have got to this point here. Then you will know that you can simplify these by 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. So these 2 ratios are the same. This one is just a bit simpler. So you could have written for every 3 rulers there are 2 pencils, or for every 2 pencils there are 3 rulers. So I've got 2 parts pencils, 3 part rulers. My whole would be 5. So you could have said 5. No, you couldn't. You could have said 3. 3/5 are rulers and 2/5 are pencils. And hopefully you can see the relationship between these fractions, because if you divide this by 3, and you divide this by 3, and you divide this by 3, and this by 3, you will see these are equivalent fractions, okay? But this one is a simpler form. And that's where these relationships between ratio and fractions come in really useful, because you can simplify them the same way that you would simplify a fraction. Okay, then 2 more. Draw shapes to represent the following ratio sentences. And I hope we all use rulers. So there's 3 triangles. So there's 1, there's 2, and there's 3. They should be the same, really, if possible, for every 1 circle. There we go. Nice and easy. Next one, there's 2 squares for every 5 circles. Right, I'm on circles, so I'm going to draw that first. So 1, 2, 3, 4, 5. Hopefully yours are all the same size rather than my slightly crazy ones. And then there are 2 squares. Nice and easy. There we go. Next one then, draw a line to match the correct shape to its corresponding ratio statement. Right. Make sure we read these carefully. For every 1 grey square, there is 1 white square. So this is a ratio of 1 to 1. So for every grey, there's a white square. So I'm looking at these. Oh, and I can see it's this one over here. Okay, I can see this one quite nicely. There's 3 grey, there's 3 white, there's 3 white, there's 3 grey. For this one then, so let's do a little G so I don't get these confused. For every 1 grey, there are 2 white squares. So will this have more white squares or more grey squares? Well, this will have more white squares because there's 2 white or 1 grey. So this one's got more white squares, so let's check it. So there's 1, 2, 3, there's 4 grey. And there's 1, 2, 3, 4, 5, 6, 7, 8. Is this the same ratio as this? Well, yeah, because all I would do is I would divide them by 4, divide it by 4. So these two match up. Let's check this one then. For every 2 grey, there is 1 white. Well, let's check it then. 1, 2, 3, 4, 5, 6, 7, 8. 8 grey to 4 white. Yep. There we go. Shade the squares in the rectangle to match the description. For every 1 white square, there are 5 grey. Okay then. Well, there's 1 white. Let's have 1 grey, 2 grey, 3 grey, 4 grey, 5 grey. 1 white, 1 grey, 2 grey, 3 grey, 4 grey, 5 grey. Was there a different way you could have answered that one? Yes, absolutely. You could have done 1 white, 1, 2, 3, 4, 5 grey. You could have had 1 white, 1, 2, 3, 4, 5 grey. As long as altogether you've got 10 grey and 2 white, you would have it correct. Right, well done. Hopefully your first introduction to ratio wasn't too scary. I hope you enjoyed that. I'll see you tomorrow.